bolt. Another oiled bolt connects the piston rod to the stroke limiting flap. Both bolts are fixed with ring discs and castle nuts and locked with splint pins. After that, a grease nipple is screwed into the bearing of the stroke limiting flap. A stop is welded to the stroke limiting flap to limit the stroke of the hydraulic cylinder towards the inside. In this way, the piston cannot strike against the bottom of the hydraulic cylinder, which helps to avoid damage. Attention! Piston rods must be protected with asbestos cloth during the welding procedure. The torsion lock for the limiting flap bolt is welded to the squeeze cylinder. The piston rod bearing bolt and the pick arm bolt are locked against torsion in the same way. Each of the 4 squeeze cylinders is equipped with stroke limiting flaps and hydraulic cylinder. A distributor block for central oil lubrication of the pick arms is mounted at the driving side of the gear case. The lubrication hoses for the pick arm bearings are connected. Before putting the equipment into operation, the lubricating system must be carefully ventilated. Wick oilers are used for the lubrication of the guide column support. The stand pipe is driven into the oil tank with the bore towards the threaded connection. A wick is introduced into the stand pipe. The strainer and the cover are mounted. An O-ring is inserted into the connector block at the gear case. The pre-assembled wick oiler is screwed in and fixed to the gear case with a holding device and 2 bolts. Both guide columns are lubricated with wick oilers. 2 vent filters are screwed into the upper side of the vibration shaft supports at both sides of the gear case. The balanced flywheel mass is transported to the unit with a mounting crane. One of the 2 keys is introduced into the recess at the shaft butt. The shaft butt is lubricated with oil. Both sides of the flywheel mass are heated with a welding torch to a temperature of 230 to 240 degrees Celsius. The hot flywheel mass is slid onto the shaft butt with protective gloves. And detached from the mounting crane. The second key is driven in. The thrust washer is placed. A castle nut is mounted. And tightened with a hammering spanner. A splint pin locks the castle nut against loosening. On the other side of the vibration shaft, the flywheel mass is mounted in the same way. The inner ring of the motor coupling is mounted on the flywheel mass at the driving side. The ring is fixed with 6 hexagonal socket head bolts which are locked with spring washers. The bolts are tightened with a torque of 60 Newton meters. The outer part of the coupling is mounted. The flywheel mass protection, which is hanging on the mounting crane, is mounted. The mounting support is screwed off. For better understanding, mounting of each oil tank is shown separately. The oil tank for pick arm lubrication. With gauge glass, filler pipe, and connecting hose. The right side oil tank for main bearing lubrication. With gauge glass, filler pipe, and connecting hose. With the installation of the hydraulic motor, the assembly of the single sleeper tamping unit is finished. In order to explain the lubrication scheme, we show a 0816 tamping unit with pick as seen from the driving side. From above, and in the diagram. First, the bearing systems which are to be lubricated with grease. The bearings of the piston rod bolts must be lubricated every 2 to 3 hours. The bearings of the stroke limiting flaps and the hydraulic cylinder bearings must be lubricated every 50 hours. The piston rod bearings of the squeeze cylinders must be lubricated daily. Now the oil lubrication. The right side oil tank is for the main bearings of the vibration shaft. Check the oil level every day and change oil every 200 hours. The left side oil tank is for the pick arm bearings. The oil level must be checked every day. These are the 2 wick oilers for guide column lubrication. The oil level must be checked every day. The tamping unit is mounted on a test bench. All grease lubricated parts must be lubricated before the test run. It is necessary to introduce grease until it leaves the bearing systems in a clean state. The oil level in the tanks is checked after ventilating the pipes. The left side oil tank is for the bearing system of the pick arms. Its gauge glass bears only one mark which designates the minimum oil level. The right side oil tank is for lubrication of the main bearing system of the vibration shaft. The gauge glass bears a minimum mark and a maximum mark. The oil level must remain between these 2 marks. Each unit works on the test bench for 6 hours. During the first 2 hours of the test run, the unit is operated with a vibration shaft speed of 1,100 revolutions per minute. During the following 4 hours, the tamping unit is driven at the operating speed of 2,200 revolutions per minute. The squeeze movements are carried out during the whole test period. This extensive test run guarantees trouble-free operation of the finished tamping unit. The temperature of all bearings is measured every 30 minutes. Bearing temperature must not surpass 90 degrees Celsius. The squeeze movements of the tamping unit. Normal position. Squeezing under a sleeper. Opening. Squeezing. Opening with tilted stroke limiting flaps. Opening width for tamping under double sleepers. normal position. The single sleeper tamping unit operating in Placer and Teurer's 0816 leveling, lining and tamping machine. Universal hydraulic detaching apparatus is used for the disassembly of Placer and Teurer tamping units. It basically consists of a hydraulic cylinder, a high-pressure pump, and different detaching instruments. Detaching a flywheel. The detaching flange is bolted to the flywheel with 3 bolts. The threaded ring is screwed onto the detaching flange. The detaching cylinder is screwed into the threaded ring. And the hydraulic hose is connected. Now the flywheel is detached from the vibration shaft with a mechanical or electrical high-pressure pump. A mounting crane is used to deposit the flywheel. For detaching the bearing body, the detaching flange is bolted onto the bearing body. The threaded ring is connected to the detaching flange. The hydraulic cylinder is screwed into the threaded ring. The bearing body is detached by means of the hydraulic pump. For detaching a piston rod bolt, a headless screw is tapped into the piston rod bolt of the pick arm. The detaching rod is tapped onto the headless screw. An intermediate sleeve is mounted, and the hydraulic cylinder is put into position. The cylinder is fixed to the detaching rod with a nut. The high-pressure pump is connected and the piston rod bolt is pulled out. A longer intermediate sleeve makes it possible to pull out the bolt completely, as it makes the stroke of the cylinder longer. For disassembling the pick arm bolt, the detaching rod is screwed into the pick arm bolt. Intermediate sleeve and hydraulic cylinder are slid into position. The cylinder is fixed to the detaching rod with the distance sleeve and the nut. The bolt is pulled out with an electrical high-pressure pump. The pick arm is opened with a hydraulic opening device and is removed. The hydraulic pick ejecting and pick introducing equipment makes it possible to change tamping picks without problems. The holding screw is tapped off. The cylinder is placed on the pick and fixed with a wedge. The pick is pushed out with a high vacuum pump.